Okay, so simplifying rational expressions. Does anyone remember what the word rational means in math class? Fraction, yeah. So anytime we hear rational, we're talking about fractions. Anyone know what an expression is? As opposed to an equation? Say it again? It doesn't equal anything, so there's no equal sign. So when we talk about simplifying rational expressions, we're taking a fraction in a problem that would have no equal sign, and then we're just simplifying it. So there is no circumstance today where you will be solving for x. Like, we're not doing that because you can't solve if there's no equal sign. Okay. So simplifying rational expressions, a couple things that you're going to want to remember is that basically to simplify rational expressions, we always want to cancel a top with a bottom. That is not mathematic language at all, but it usually makes sense to students. So if we look at our warm-up right here, on number 1, for instance, in the original problem, we had a b to the 4th on the top and b a to the 2nd on the bottom. And so what we did to get b to the 3rd as the answer is we said there was 1 b on the bottom and 4 b's on the top, and so I could cancel out one of those on the top and the bottom, and then that would leave just b to the 3rd on the top. And so that's how we think of simplifying. Or if we look down at number 10 originally was 16 over 56, and you could think of that as 8 times 2 and 8 times 7, and the 8 on the top and the bottom would cancel. So whenever we simplify fractions, we're basically just canceling something on the top with something on the bottom. That's how we simplify. So we're going to remember that for today for when we do more difficult problems. The other thing that we want to do is remember that factors are separated by multiplication. Which means that we're going to see them written as like parentheses next to parentheses, right? Are we used to seeing factors written that way? And then one last thing, we're going to say anything with a plus or a minus in between is considered to be one factor. And I will point that out when we get to one that's like that. So anything with a plus or a minus in between is considered to be one factor. So for instance, like x minus 5 is considered to be one factor. X plus 7 is considered to be one factor. Alright. So here's our first example problem. We're going to do 3. If you wrote small, you can probably get all of it on the front side of this sheet, but if not, you can flip. There's a back side. So we're only doing 3 examples. So if we have 18x to the 3rd over 24x to the 2nd, this is kind of like the warm-up problems you guys did. It's just like a combination of the top half and the bottom half. So we're talking about numbers and variables at the same time. So this is still, I would say, a Math 2 level difficulty problem. This is not quite Math 3, but it's getting there. So the first thing we would do is look at the numbers, 18 and 24. Do you guys see a number that we could take out of both of those? 6? Okay. So if we divide out 6 on the top, what do we get? 3. And if we divide out 6 on the bottom, what do we get? 4. So on the top we're going to have 3. On the bottom we're going to have 4. And then we also want to simplify the x to the 3rd over x to the 2nd. And what would that leave us with? X. And would the x be on the top or the bottom? Top. How do you know it's the top? It had more. It had more of them, so it would have had the one left. Okay. So the simplified expression is 3x over 4. Now one thing, and I think it was, did you say you need a packet? They're up there. There's a stack of them on the table. Does that mean you didn't do your homework? Yes, that's what that means. Alright, so there's one thing I talked about in the video when we're talking about plugging in values for x, like if I wanted to evaluate the expression and say like, let's tell me what the expression is if I plug in 5 or something like that. There are specific values that we're not allowed to have because we have a fraction. So what is the main rule about the number that cannot be on the bottom of a fraction? There's one number specifically we cannot have. You can't have 1 on the bottom of a fraction? You can't have 0 on the bottom of a fraction. So if you grabbed your calculator and you tried to type 5 divided by 0, what would your calculator say? It'd say nope. It'd say error, right? It wouldn't let you do it. So we can't have 0 on the bottom of a fraction. So what that means is when we're plugging in values for x, there's always going to be, well not always, but usually going to be a value for x that we are not allowed to use. And we call them excluded, I should have written values, excluded values is what we call them. And we always write it as x does not equal. So what that means is we're going to have one value that you can't use for x, and then any other value, if they wanted to evaluate it using another value, that'd be totally fine. And whenever you look at your excluded values, we always look at the original problem, not the simplified problem. Alright, we're going to look at the original. So looking at that, we have 24 multiplied by x squared. Anyone have an idea of what number, if you plugged it in for x, would make the whole bottom equal 0? Now if you did 24 multiplied by negative 24 squared, that would just be a huge number.
0.
So it's 0, yeah. So when you have a problem like this, this is called, the bottom is called a monomial. It's one piece or one term. Anytime you have a monomial on the bottom, the value that's excluded is 0. So if we did 24 times 0 squared, that would just be 0 on the bottom, and then our calculator would give us an error message. We can't do that.
Is it always going to be 0?
If it's a monomial on the bottom. If it's just one thing.
Like yesterday they were like...
It was like x plus 5 or something, and then you're right, you would do the opposite sign, which is what you were thinking, yeah. Okay. Here's the next example. We're going to say that we have 7x, there should be an x there, 7x times x minus 1 over 3x times x minus 2. So 7x times x minus 1 and 3x times x minus 2. I thought that would fix it, but it really didn't. Is that better? Oh, there we go. That's better. 7x times x minus 1, 3x times x minus 2. Okay. So we are looking for things on the top and the bottom that can cancel. Do you guys see anything?
The 7 and 3.
I agree, not the 7 and the 3, right? Because 7 over 3, those would not divide out. But what about the x and the x? Yeah. So the x and the x can cancel. Those can go away. Alright. Say it again?
The other x's and x's.
Yeah, now this is the part we have to be careful about because we have these factors, x minus 1 and x minus 2, and since there's parentheses around the x minus 1, it's considered to be a group. So if you want to cancel out the x minus 1, then the whole group has to go. You can't just cancel out the x with the x. So this one, would you say that x minus 1 and x minus 2 are identical? No, then they can't cancel. They have to be exactly the same. So over here we had an x and an x. Those two x's, those were considered identical. They were just by themselves. But these ones, since they have a minus in between and there's parentheses around them, they're considered to be one group, and so we can't cancel them unless they're exactly the same. So at this point, this is actually as far simplified as you can get. So we're going to say that this is 7 times x minus 1 over 3 times x minus 2. Now, the reason that we can cancel these two x's right here is because if the x is written right next to parentheses, what does that mean as far as the operation? Is that plus, minus, multiply, or divide? That's times, right? What about this x right here next to this parenthesis? That's multiply as well, right? And then what's the little fraction sign mean? Divide. So would it make sense that multiply and divide would be things that cancel each other out? Yes. Now, if we look at these x's right here, you have x minus something, and down here we have x minus something. So would it make sense that minus and divide cancel out? No, those don't necessarily make sense. Okay, so that's why the first x's cancel, but the second ones don't.
Feels x plus 2 and then x minus 2 would cancel out.
They'd have to be exactly the same. So if you had x minus 2 on the top and x minus 2 on the bottom, those would have canceled because they'd be the same. Okay. Alright, so this is our simplified answer. Now we want to figure out what our excluded values are. So right here, this part that is 3x, if I just look at the 3x, that is called a monomial. That's by itself. And so what was the excluded value we just talked about that you're going to see every time it looks like this? 0. So here we're going to say our excluded value is x cannot equal 0, and that's specifically because of this one right here. What's the excluded value for the other one? What is it? 2. Yeah. So for this one, we're going to say x cannot equal 2. So you can plug in 5 in this problem, you can plug in -1, you can plug in -3, you can plug in 19 million, you can plug in all sorts of things, you just can't plug in 0 and you can't plug in 2. Because it would make your calculator give you an error message. Okay, and then last one, this is the one that's like especially the Math 3 level of what we're going to be doing this unit. So this one is x squared plus 9x plus 20 over x squared plus 13x plus 40. And this is where you have to be careful. Since there are plus signs in between these, this is considered to be one group or one factor, and the bottom is considered to be one factor. So I have students all the time that are tempted to cancel out the x squared right here and the x squared right there. Why can I not cancel those out? Yeah. Yeah, they're not, you said opposite of each other? What do you mean by that? It is kind of hard to explain. I agree with you. It's kind of hard to explain. Because what comes after the x squared? It's a plus sign, right? So these things are being added, and these things are being added. So if we cancel, then we're trying to say that division cancels with adding. Is that true? Division does not cancel with adding. Okay. So if right now we have a factor on the top and we have a factor on the bottom, and right now they are not identical, so they don't cancel. Is it possible to factor the top and the bottom further than they look currently? Yes. Okay, so let's go ahead and do that. So this is 2 diamond problems, right?
You don't have to do that.
You don't have to write it like that, but you're going to have to do that method of factoring, basically. Yeah. So for the first one, we're looking for something that multiplies to 20 but adds to 9. 5 and 4. So for the top we have x plus 5 and x plus 4. And then for the bottom one we're looking for numbers that multiply to 40 and add to 13. 8 and 5. Okay. So now, since these 2 factors on the top are separated by parentheses, this factor on the left and this factor on the right are being multiplied together. So we have multiply on the top and we have multiply on the bottom, and we have division in between. So now if we wanted to cancel something on the top and the bottom, could we? Yeah. So now we can say, alright, things on the top are multiplying, things on the bottom are multiplying, and in between we have division, and multiplication and division truly do cancel each other out. So which are the ones that you guys would like to cancel?
X plus 5.
Yeah. So x plus 5 and x plus 5. Now, it's very tempting for us to cancel the x's and the 4 and the 8 and the leftovers, but are we allowed to do that? No, because there's a plus sign in between these. And plus and divide do not cancel. So our final answer for this one for simplification would be x plus 4 over x plus 8. And what would we say if we wanted to write what the excluded values are? So we do not look at the simplified form, we go back to the original problem. What values can you not use? So x cannot equal negative 8.
I thought you went back to the original.
Sorry. Go back to the one that has the factors before you canceled. Yeah. And then if you look, Joey, if you look at the original, this is not considered a monomial, it's a trinomial. There's 3 pieces, and so we wouldn't automatically say 0 was one of them, because it's got 3 terms. Okay, so for this parenthesis, x cannot equal negative 8, what